in this video, I'm going to show to you the various methods of detecting radioactivity, okay? And we've got loads, very, very fortunate to have loads. So I'll start off with a simple GM tube student-friendly version. With no sources around, I'm still able to detect clicks. That's because it's detecting background radiation, which is an error, and you have to take that into consideration. So if I get one of my radioactive sources, and just to show you how it works, I've also got an alpha source here. If I turn that on, point into it, there you go. So the number of clicks will be the number of ionization particles that are coming out. So GM tube, okay? We tend to use this for GCSE. However, we've got a more advanced A-level GM tube. So this is the GM tube, but that is actually the counter, or what they can also call the scaler. And you reset it. That's your receiver. So you put it in here, and you can see that it's actually picking up the radiation. I'm not going to do this practical. It's only for demonstration. So that's our, A-level version of our GM tube that we've got. And there's a few more exciting ones. This over here is called a cloud chamber. And we use it to show, we can actually observe the tracks. And what you do, you take a bit of alcohol and you put it on top. So a few drops of alcohol on top. And then you'll immerse your alpha rod in here, the one that shoots at alpha. And you wait for a bit. So we got a fan under, and it blows the ethanol, which then turns into a vapor. You've got to wait for it to be super saturated. Once it's super saturated, as the alpha particles come out, the vapor condenses onto it, and that allows it to be visible. The one that we haven't got, which is similar to this, is actually a bubble chamber. So this is called a cloud chamber, very useful as in alpha tracks.
Oh, so beautiful.
Yeah.
Yeah, exactly.
That's right.
Oh.
Because it's not really a strong source.
Very
That's
cool.
right.
A bubble chamber we haven't got, very difficult to make, very expensive. So we're going to put that aside. What are we left with? Oh, we're left with a spark counter. Right, we know that alpha particles are positively charged, beta particles are negatively charged, and gamma are neutral. This is called a spark counter. It's basically a little grid that looks a bit like this. Just a metal grid connected to a very high voltage of around 4,000 volts here. So that's around 4,000 volts, very dangerous. And look what happens. If I take my alpha source being positive, oh, look exciting. So this is called a spark counter. So the number of alpha particles that are getting into this high electric field, there's a short circuit and it gives you a spark, and that is used to detect radiation. Gold leaf electroscope. So a gold leaf electroscope can be charged. So what I've done earlier, I'm just going to charge it. So if I charge my gold leaf, there you go. So that's all charged. And what do I want to do now? I want to bring my source. Now, it's not great at detecting radiation, but it actually shows that because a gold leaf electroscope can detect charge, I'll bring that closer. There's a tiny bit. It's actually going down a little bit, and it's detecting that there is a radiation that's coming out, an ionizing radiation. And finally, the last one that I've got is photographic plate. So the sort of thing that Mary Curie would have used. And when you go to the hospital, this is an example of a hip replacement that someone had, courtesy of the hospital actually. If we expose this to radiation, especially gamma, right, that part, the dark part, is actually going to be changed. So when you go to when you have an X-ray at the hospital, this is what they use. When X-ray hits it, it changes the color. Gamma, even more powerful, high energy than X-rays, will develop the film for you, and that allows us to detect radiation. So just to reiterate, cloud chamber, Geiger-Müller tube with a scaler or a counter, and then we've got our spark counter, gold leaf electroscope, and photographic plates. The one that we haven't got is the bubble chamber. What else? Oh, there's also the solid state detector, and that uses semiconductor, again, which we haven't got. Thank you.